Hi folks, we're back, and as promised, we're still working with arc length, and we're going to do one of them with the formula with y as our variable instead of x as a variable, and we've got another word problem after that. It's just these two slides, if I remember correctly. So let's see, here's our formula with y up here. So find the arc length of the graph of y minus 1 cubed equals x squared on the interval from 1 to 8. So now we could actually do this one either way. We could solve for y here, or we could solve for x. So we could do either one we wanted to. All right, we've got the points at both endpoints, so we know where we're starting, we know where we're ending. So one way to do this, if we're doing this with, well, let's hold off on that. If we're doing this with x equals a function of y, like x equals g of y, we need to solve this for x. So we just need to take the square root of both sides. So we'd get y minus 1 to the 3/2 equals x. That's the easier one to solve for. So now, the derivative of x with respect to y, I know it feels weird writing dx dy. We just do a chain rule here. So we bring down the 3/2, y minus 1 to the 1 less exponent, so to the 1/2, times derivative of the inside. Derivative of y here is going to be dy over dy, which is just 1, so we don't have to worry about that. All right, so there's our derivative. So our arc length formula will be the integral. If we're going along y, we're going from 1 to 5. Of the square root of 1 plus this guy squared. So that's 9/4. Y minus 1 to the 1/2 squared would be to the first dy. And that's not so bad of an integral. It's actually probably not something I want to actually integrate, but that's not so bad. We can just take that and throw that into our calculator from here. And yeah, I am kind of getting lazy and doing a lot of them with the calculator from here, but that's okay. If we have that option, take that option. So math 9, we're going from 1 to 5. We've got the square root of 1 plus 9 over 4 times, I said plus, I wrote minus. There it is, plus y minus 1. We don't have y, so we're just going to use x minus 1. And we don't have it, we used x instead of y, so again, we'll just use x here. And that gives us 9.073. And there's our answer. All right, we could have solved this out and worked this out, and we would do some substitution with what's inside the square root here, and we hopefully would have still gotten the same answer with some square roots involved. And if we did this with, like if we did the other way around, if we solved this up here for y, let's see, y minus 1 equals x to the 2/3, add the 1 over, and then take the derivative, dy dx equals 2/3 x to the negative 1/3. And then we'd get that the length would be the integral from 0, so we're going from 0 here to 8, 0 to 8, of the square root of 1 plus 2/3 squared would be 4/9. X to the negative 1/3 squared is x to the negative 2/3 dx. That integral is a much tougher integral to take. So we couldn't just do regular old substitution here because this is not a linear term. We could do regular substitution here. So this integral would be very difficult to try and do by hand. This one, however, would just be regular old substitution, and we could probably do that. All right? And if we threw this in the calculator, we should get the exact same thing, 9.073. It might be off by a little bit, but that's just your calculator getting slightly different answers. All right, an application. So I've heard they use this problem, or Google uses this problem when they do their interviews, is to figure out the length of a cable that hangs between two endpoints. All right, so an electric cable is hung between two towers that are 200 feet apart. The cable length takes the shape of what's called a catenary, which is the shape of a hanging cable. It's like a parabola, but not quite a parabola, whose equation is given by that. All right, find the arc length of the cable between the two towers. All right, well, we've got the equation, so we just need the arc length of this guy. So, well, we need to first take the derivative. We take the derivative, you still got the 75 out front. All right, we're going to get 1 over 150 e to the x over 150. This derivative of the exponent is just going to be 1 over 150. Here, the derivative of the exponent is going to be negative 1 over 150 e to the negative x over 150, like that. We can pull out the 150s, and they'll cancel with that 75 and leave us with a half. e to the x over 150 minus e to the negative x over 150. All right, and then we want to square this. So our arc length will be the integral from, okay, now here's where it gets weird. We're going from negative 100 to 100. Right, negative 100 to 100. We could also go from 0 to 100 and just double it because it's symmetric. So we could go from 0 to 100 if we wanted to. But we're going to probably need to do this in our calculator anyway, so it's not going to make much of a difference. So we get 1 plus this whole thing squared. So 1/2 squared is 1/4. We get e to the x over 500, or 150, not 500, minus e to the negative x over 150 quantity squared dx. All right, from here, I'm going to go to my calculator. I know you can actually do this by hand, and it works out to something nice that you can factor. I think it just becomes this guy with a plus sign in between, but in the interest of time, we're just going to go math 9. We're going from negative 100 to positive 100. And let's see, we've got the square root, second square root, 1 plus 1/4 parentheses e raised to the x over 150 out of the exponent minus e raised to the negative x over 150 out of the exponent, close the parentheses, out of the square root, out of the integral, and we say our variable is x. And our answer is 198.963. All right, and there's our guy. And let's see, we were in feet, so don't forget we want to put some units here, feet. All right. So we're, that doesn't seem quite right, does it? Did I leave off the squared? I did leave off the squared. I was like, okay, now the reason why that didn't seem right to me is because I actually checked my answer and I said, okay, we're going from negative 100 to 100. It should be at least 200 feet. If it was a straight line, that would be 200 feet, right? So I noticed, looks like I made a mistake somewhere, and I did. I left off that squared. So it's always good to check your answer. So just to fix that, we press second enter. We get that last answer, and we're just going to go back in here, inside the square root. There we go, outside the parentheses, squared. There we go. Aha, didn't forget it. Hopefully some of you at home are screaming, hey, Robeson, you forgot the squared. There it is, 215.1475, so on. And there we go. Now that seems like a reasonable answer because it's a little bit longer than 200 feet, and it should be dipping down, and that dip down is adding that extra 15 feet or so. All right, so now that makes sense. Good catch, guys. Good job. All right, so that's it for arc length. So go ahead and get started on the homework. Hopefully the homework isn't too bad, but you know, 1 or 2 of them will be word problems. Just warning you.